Alright, this next section, 5.3, is all about classifying triangles. I'm going to introduce some new material on the front side, and then on the back side we'll try a bunch of different types of problems. So, this very first problem here, or this very first idea here, is that you have a triangle, and it says that side AC is bigger than side BC, which is bigger than side AB. So let's just hypothetically say that this side's 10, 9, 8, right? AC is the biggest side, BC is the next biggest, and then AB is the next biggest after that. The question is, if I look at the angle measures, which one is going to be the biggest? And if you think about it, think about this like opening up a mouth. Okay, this is the opening for a mouth, and this is how wide you're opening the mouth. This angle is going to be the widest opening because it's opposite of the biggest side. And the same thing is true about like the number 8 here. This side here is the smallest side, and so this opening right here is the smallest opening because this side is the smallest side. So if I'm trying to figure out the angles from largest to smallest, the largest angle, of course, would be angle B, which is opposite the biggest side. And the next biggest would be angle A, which is opposite the next biggest side. And then the last one would be angle C. So angle C would be the smallest, and angle B would be the largest. Okay, next concept is something called the exterior angle theorem. So for a triangle, there are exterior angles. By simply extending one of the sides of the triangle, that becomes an exterior angle. And so angle 1 here plus angle 2, we know, form a straight angle, so it's going to be 180 degrees. And we also know that angle 2 plus angle 3 plus angle 4, okay, so the three angles of the triangle here, 2, 3, and 4, also add up to 180 degrees. And notice, this is the same, this is the same, so therefore, this has to be the same also. So in other words, angle 1, which is your exterior angle, is equal to angle 3 plus angle 4. So, the exterior angle is equal to the sum of the two remote interior angles. That's what they're called, remote interior angles. So remote means furthest away, okay, furthest away from the exterior angle. Interior means it's inside of the triangle. So the exterior angle is equal to the sum of the two remote interior angles. Okay, next concept here. Can you make a triangle with lengths 4, 7, and 100? 4, 7, and 100. So if this side was like 100, then this side would be 4, and this would be like 7. I don't even think that's drawn even remotely close to scale, but hopefully you can see that you can't do it. If I just have sides 4 and 7, there's definitely restrictions on what the third side can possibly be. And so the restrictions on that third side, let's call that third side X. Okay? That third side X, if I know my first two sides are 4 and 7, have to be between the difference between 4 and 7 and less than the sum. Okay, so the third side has to be between the difference and the sum of the two original sides. So in this particular case, if my sides are 4 and 7, I know that the third side has to be, okay, call it x, has to be between 11 and 3. Okay, and it can't be equal to 11, it can't be equal to 3, it has to be less than 11 and greater than 3. Okay, some more information here. Information that, quite frankly, you probably have seen in past years, so I'm not going to spend a huge amount of time on this, just more as a refresher. Okay, so here's a scalene triangle. A scalene triangle has 3 sides and 3 angles that are not congruent to each other. An isosceles triangle has 2 sides that are congruent to each other, and we know that the base angles are congruent to each other also. This is the base. This is what we call the vertex of an isosceles triangle. An equilateral triangle has all 3 sides congruent to each other, and so therefore all 3 angles are congruent to each other. And we know, since the angles add up to 180, these angles must be 60 degrees. And when we have 3 angles equal to each other, we call that equiangular. An acute triangle has all 3 angles are less than 90 degrees. A right angle has 1 right angle. An obtuse triangle has 1 angle that's greater than 90 degrees. Okay, so let's jump to the back side. Let's take a look at some problems on the back. Okay, here we are on the back side. The first problem here, we're going to take 6 triangles and we're going to classify the triangles according to their sides and angles. So for example, the first one here has 3 sides that are not the same, so we're talking about scalene and angles. We have 1 angle here that's bigger than 90, so that's going to be an obtuse triangle. Now, one thing that I happened to notice when I was keying this earlier is that this triangle actually doesn't exist. Now, I don't know if you can see why, but basically, if you look at the sides of the triangle, they don't work. So for example, if I take 8 and 20, and I said, what's the third side? Well, we know the third side has to be between 12, the difference, and the sum, which is 28. And unfortunately, this side does not. So truth be told, this triangle doesn't exist. Okay, I will try not to do that a whole bunch, but that did come up in this case, and it also comes up in this case here. Okay, and the reason why is if you look at the angles, the side opposite this biggest angle right here is the biggest angle. That's not the biggest side, so that's a messed up problem also. The rest of the problems do work. So this one ends up being an isosceles triangle, and it's an obtuse isosceles triangle. This one's going to be a right triangle, and it's going to be scalene because none of the sides are the same. This one's going to be equilateral and equiangular. Equilateral, equiangular. And this last one's going to be a right isosceles triangle. Okay, 2 sides, the legs are congruent to each other, and it's a right triangle. Okay, problem number 2 here. Looking at the perimeter of this being 25, AB is x plus 1, BC is x squared plus 3, and this third side is 4x minus 3. With the perimeter being 25, hopefully you can see that you just take these three sides, add them up, and set it equal to 25. So you're going to get a nice little algebra problem here. It's been a little while since we've done some fun algebra. When I solve this, I get x squared plus 5x minus 24 equals 0. Most of these are factorable. Most of these quadratics are going to be factorable, so it's going to be x plus 8 and x minus 3. So x is equal to negative 8 or 3. Now I got to plug these in to see if they work. What I mean is, like for example, if I plug in negative 8 right there, you're going to get a negative side length. And we know you can't have a negative side length, so that does not work. Okay, don't just cross it out just because the x value is negative. Sometimes that actually does work. But 3 does work, and so when I plug it back in, this side ends up being, I believe, 4, this side is 9, and this side ends up being 12. Okay, moving on here. I think I'm going to jump down to the bottom here. And so the following triangle is equilateral. And so solve for x and y. So what I'm going to do here is, I know that these sides all have to be the same. So I'm going to, and I realize there's x's and y's here, so I need to set up a system of two equations. 2 variables, 2 equations, 3 variables, 3 equations, 1 variable, 1 equation. So in this case, I need 2 equations. So I'm just going to do like x plus y equals 15 minus x, and like 2y plus 3 equals x plus y. And I'm going to solve that system. So when I do solve this system, hopefully you remember how to solve a system from earlier in the book and from last year. You should get x is 6 and y is 3. Go ahead and try that to get that. You should, as a little refresher, hopefully be able to do that. Okay, I think that's it for now. I'm going to let you go ahead and try some of the problems on the homework. All right, good luck.